So if we want to construct a frequency distribution, here we are given a sequence of 5 steps with a couple of sub-steps in there. What we want to do is first choose the number of classes where usually we're going to pick something between 5 and 20, and often we're not actually picking this, it's going to be stated in the problem. Then we determine the class width. Where to get the class width, what you do is find the range of the data, divide by the number of classes, and round up to the next convenient number, where I consider the next convenient number to be the smallest decimal value in the data set, but there's a little bit of leeway in terms of how that value is defined. Then, once you have the class width, you determine the class limits, where to get this, you start with the smallest value in the data set and make that your lowest class limit, your first lower class limit, and then you add the class width to that until you get to the number of classes. So if you have 7 classes, you'll add the class width to that lowest one 6 times to get 7 lower limits, and then you'll knock off 1 from each of the first 6 to get their upper class limits, and then add a class width to get the last upper class limit. And then from there, you make a tally for how many times you get data in each of those classes, and count up those tallies to give yourself something meaningful in terms of frequencies. Give yourself those total frequencies. And you don't necessarily need 5 and 6 if you're really comfortable, but 5 is a nice intermediate step there on the way to 6. And with this, I'll say that my biggest problem with this entire construction is step 1. Because when it comes to this kind of idea, the number of classes is, in my opinion, the least important part. When you have a data set, usually there's going to be a nice pattern that the data would fit naturally. You know, if you have data that's between 0 and 100, you'd probably want to fit it by tens. Because the point of this type of construction is to be able to recognize patterns, not just when you look at it, but when any layperson might look at it, they can go, oh, okay, I understand why this is meaningful. So you get a number of classes that fits a nice pattern. You don't pick your number of classes and then force your width into some nonsensical value because getting 6 classes was more important to you than having your width not be 7.4. You know, you make it so that you have a value that is actually meaningful to the data set, but building it this way makes it easier to test on. At least that's my understanding of it. It's why I'm not crazy about this stuff. Part of why I'm not crazy about this stuff. But we are still going to go through this process here, so you have one good example of how it can be done.